Okay, so this is what we're going to do today. Okay, but before I start doing, okay, I want to thank all the angels out there. If you look at our Q&A sheet, you will notice that there's a lot of angels around who is trying to help one another by answering questions. Okay, let me show you what I mean. Okay, can you see? All these are actually angels answering. I don't know who you are because you don't leave your names, right? Okay, so I will just call you angels. Okay, so you actually try to help to answer a lot of the questions already. Okay, so this is what we mean by a community living, community sharing. Everybody do it together. Can? Okay, come, let's go. So for question number 1, this whole paper I hope is manageable for you. Okay, because I look at the responses that you are helping one another to answer. I think this paper provides confidence for many of you, I guess. I hope so. Okay, now, question number 1. Okay, question number 1, not much question, just mainly about, for 1A2, you ask why is there a coefficient for 3 for the carbon monoxide. This one don't have the coefficient. Because if you notice, I think the balancing wise, okay, with 1 mole of carbon monoxide, it actually balanced the thing already. So this one don't have. Okay, so whoever asked that question, thank you. Okay, I want to go through a little bit about question number part 3. Okay, I know nobody asked this question. Okay, but I just want to highlight a point here. Okay, I don't know what you write, but I just want to highlight it's all possible intermolecular forces. So when I say all possible intermolecular forces, I mean everything. So it's not only your IDID and your PDPD. It's not only your PDPD, it's also your IDID because it's all. And the interesting thing about this is that they ask how these forces arises. So I think we've been doing quite a number of papers, but I don't think we've seen anything that asks you how it arises. So this paper creates the exposure for you. You need to know how the IDID forces of attraction is actually formed and why is there a PDPD. Okay, so basically it's the concepts inside your note. Okay, so this is something that we need to learn as well. Okay, this one nobody asked, so I think it's quite okay. This one also nobody asked. 2A2 got people ask. Okay, 2A2 got people ask. 2A2 is talking about this, whereby I talk about the hydration energy. Okay, hydration. Now, the question that is being asked is, may I talk about I minus being bigger so it can form ion dipole interaction with water molecules as compared to Cl minus? Okay, now, then the next question is, how do I know that I'm supposed to talk about charge density? So I think this student probably went to ChatGPT, okay, and find out that the hydration number for I minus is actually different. Okay, so I also use ChatGPT. Okay, I guess you use ChatGPT, so I also go ChatGPT to see what ChatGPT tells about it. So here, okay, ChatGPT did say that I minus bigger, so there's more water molecules that can surround it. Okay, but they also say that the hydration enthalpy is finally still less exothermic because the ion dipole interactions are weaker. Now, then the next question I ask is, or you ask is, can I talk about this in my A-level exams? Okay, very much we still want to scope it to our H2 syllabus. Okay, so in a H2 syllabus, when we talk about hydration, we link it to charge density. Okay, so some of you might be thinking, how is it linked? How is it linked to hydration? How is it linked to charge density? Now, you have to understand that hydration, enthalpy change of hydration is the formation of your ion dipole interaction. So when you form an ion dipole interaction, when the charge density is higher or larger, okay, the interaction that is formed is actually stronger. Okay, and that will affect the magnitude of your hydration, enthalpy change of hydration. Okay, so that is why if you notice in the answer here, they talk about larger. Okay, they talk about ionic radius. Okay, I think you have learned enough that when I ask you for appropriate data from the data booklet, you have learned enough that you need to quote some stuff from the data booklet. Okay, so this question is a 2-mark question. I believe there will be ticks given for ability to quote the data from the data booklet. Okay, so you don't want this tick to go to waste. Okay, now you also notice that in this case, the question asks in terms of the magnitude. Okay, the question asks in terms of the magnitude. That's why the answer is the magnitude for the hydration energy is smaller. I want to hereby, okay, remind everybody, if I never talk in terms of magnitude, but I talk in terms of enthalpy change of hydration, you have to give your answer in terms of more exothermic or less exothermic. Don't use the word smaller, bigger, increase, decrease. It is very ambiguous because enthalpy change of hydration is negative, is exothermic. Please remember this. I think you got penalized before last year when we tested this concept or the similar stuff in the lecture test. Okay, so learn from your mistakes and don't do it again. Can? Okay. So this one is the hydration one. The next one that people is asking is about question B. This is 2B2. Okay, 2B2. Question asked is, may I know what is the thought process behind the answer to this question? Okay, so let's talk about the thought process. So in this case, what am I talking about? I'm actually talking about your sodium chloride, your sodium iodide. Okay, they give you the experimental value, they give you the theoretical value. So what does the theoretical value means? Theoretically, I will assume, okay, my AGC, no, not NaCl, sorry, my NaCl and my NaI, okay, to be pure ionic. That means to say the Na is a transfer electron to the Cl minus and pure ionic. So that is the theoretical value. But when you conduct the experiment, you notice that the experimental value is different from it. Okay, then what is the thinking process behind this? You have to start thinking, what causes the difference? So on one end, I assume it to be purely ionic, but in actual fact, it seems like it is not. Does it relate to something that you learn in your syllabus that is very outstanding to you? Okay, if you recall in chem bonding last year, you learned something very special about your AlCl3. Remember? AlCl3 is also supposed to be, Al is supposed to be group 13. Okay, your Cl is supposed to be group 17. So by right, we think that it should be a pure ionic. But because of what? Because of the high polarizing power of my Al3 plus, okay, it is able to distort the electron cloud of the Cl minus. Am I right? So that's why NR it becomes a covalent. The extent of the distortion is so much so that it becomes a covalent compound. Then that is the one that rings in your head. Yeah, I got such special case. So then now I need to apply this to my knowledge again. Okay, because the theoretical value and the experimental value is not the same. So why? Then you start to talk about the polarizability of your I minus. Okay, then you talk about it having a covalent character with a ionic bond with covalent character. Okay, the next common one that people will would like to test, or you have seen it before, it's your AG. If you recall in your chem bonding, I take it out from your chem bonding. Okay, this one, silver fluoride and silver iodide. Okay, also like sodium, there's close agreement, but there is not close agreement for silver iodide. So same thing here. Can you see? This one you can refer back to your tutorial, chem bonding. I pluck it out from there. Okay, so you have been exposed to this type of question before. If it happens again or something similar comes out, okay, maybe probably AG or NA or whatever it is. Okay, but you notice that there is a part whereby they say theoretical, experimental difference and words of the same effect. You can think in that direction. Okay? And so that is my question for 2B. Let's look at now question 3. Okay, for question 3, now this question, to be honest, I am very surprised that they actually give you 3 marks for this. This one is easy to get, right? This 3 mark is easy to get, right? Just plug in all the values and then, okay, just to check, know how to get the salty and the bitter or not? Anyone got problem with this? Don't have, okay. So you all know how to get that salty and the bitter. Can. Okay. Okay, I want to talk about the one that is asked. Where is it? Okay, this one. 3D part 1. How do I form the structure with 2,4-DMPH? Okay, how do I form the structure with 2,4-DMPH? So the student is asking about this. And the angel say, you need to know how to draw the structure of 2,4-DMPH first. Okay, you see our angel? You look at our angel. Okay, I make it bigger for you. Our angel teach the student how to do it. Here. See, our angel say you must know the structure of 2,4-DMPH, then you remove 2H and blah, blah, blah. So the angel is trying to type out the process. Okay, but on the basis that the student must know what is 2,4-DMPH first. Okay, so now my question to you is how to remember the structure of 2,4-DMPH. It's a very big thing, right? 2,4-DMPH, 2,4-dinitrophenylhydrazine. So I'm going to teach one time, you remember, and then after that you draw. Okay, so 2,4-DMPH, right? So it's dinitrophenylhydrazine. Okay, so first thing you must know is that you see that the thing is actually a hydrazine. Okay, so you must have your hydrazine first. Okay, so this is your hydrazine. 2,4-dinitro means what? At the second position, at the fourth position, I have my nitro. So I settle my 2,4-DMPH. Okay, then how do I get the structure? Now, in this case, the 2,4-DMPH reacts with only the carbonyl, correct? So the carbonyl in this case is here. Okay, the carbonyl in this case is here. I will draw it as a R, C double bond OH. Then how? What should I do after that? You know that water is eliminated, right? You know water is eliminated. Then how? It will be, let me use another color again. You have your O. Okay, this is where your water is eliminated. So you just need to give me your okay, then you go and draw the rest. Oh, sorry, no more N already. No more H already. Okay, this is how you get your answer. And I didn't draw out the big stuff. I call it N. Call it R. You can just draw it out on your own. Okay, if not, then you do a define. You say define R is whatever, whatever. Then you just define it. Okay, then that will save you some time. And so this is my 2,4-D and pH. For A1. Okay, now, do you notice this one type of reaction? Okay, type of reaction is something that you cannot run away. So you need to know the type of reaction. 2,4-DMPH is condensation because there is a water molecule that's coming out. This one, HCN, is a nucleoadd. This one is a electrophilic add. Okay, so this one, it all goes by your functional group. Okay, you see what is the functional group that undergoes the reaction. And from there, you'll be able to determine the type of reaction. Okay? Next, for A1. Now, for A1, what are they testing? They are testing you this. This is an often neglected section in the notes. If you look at your 2024 paper, 2024 paper 3, question number 2, deals with this as well. Okay, 2024 paper 3, question 2, part A, deals with this. So you will notice that it's gaining recognition now. Okay, so please go and learn it so that you know how to do the answer. Okay, so they ask you to describe the row. You just need to describe the row. So nothing much. Okay, next. There is a dot and cross diagram for NO2 indicating any coordinate bond, additive covalent bond. So this one is not difficult. I want to have an extension with you. Can you have 1 minute now? Can you try to draw me my N2O4? It's not asked in this question, but because it's related, so I give you a little extension. How are you going to do your N2O4? 1.5 minutes. Starts now. Try drawing it. How you draw your N2O4? Okay, let's see. Okay, so how would you draw your N2O4? If you look at the equilibrium, N2O4 is actually your NO2, two of it, right? Okay, so it's actually just the combining of my N and N together. Am I right? I combine my N and N together, I get my N2O4. Okay, so if I'm going to draw it like that, you will notice that it's just the combining of your N and N. Okay? Okay, your N did not explode. Okay, so it's just a 2N2O4, 2NO2 combining together. Okay? Can. Let's move on. This one is okay. This one is okay. Okay. This one. Something to say about the answers. C part 2. C part 2. Just to highlight something about the answers itself. You notice that in this case, when temperature increase, the equilibrium position will shift to the right to absorb the heat added. But I think in our college, we usually say the equilibrium position will shift to the right to absorb some of the heat added. Okay, so we will add in the some. Okay, so just follow our college will be good enough. Okay, nothing much here. This one. Okay, so there is a question here to say that for the mechanism itself, may I know if I draw HSO4 minus attacking the H in the middle? I did not do this. But for the first step, I added back. Okay, my answer to you is just follow your school notes, which is our notes. Okay, so that will be good enough. Okay, but this one will be a good point to learn. This one will be a good point to learn when you know that this O, okay, O actually has the lone pair of electrons that is going to form a bond with the H. Okay, this one is a good learning point, but for our colleges, we just write the HSO4 minus because it's a fast step. Okay, so just follow our school notes will be good enough. Okay, next. Let's look at question number 5. This is the data response question. Okay, so there is a question asked, how do you get the oxidation number of oxidation state of CO in COO2? Okay, so they are asking about, the student is asking about the second one. Okay, now, first of all, COO2, I think it's quite easy. But if I have a LiCOO2, what do I have then? Li will have a positive charge of +1. Okay, my Li will be +1. Then my COO2, oh sorry, too many big C's. COO2 will then become your minus. And from there, you will get your +3. Okay. Next. This one, I think there is someone who asked about this somewhere for 5B. Why is the cathode a graphite electrode? As the question says, the cathode is the cobalt oxide. To be honest, initially when I'm like you, I also thought the answer is wrong. Okay, but if you read again, when I read again, look at this thing. They say that if the battery is overcharged, and in this case, they say when a battery discharge. So you know that the charging process and the discharging process is reversed. Correct? So in this case, the lithium will be formed in the cathode, which is the graphite electrode, because it is now the charging process, not the discharging. Okay, so I have to take note. Okay, this I mentioned already. This one done. Oh yeah, someone asked about this and Angel also answered. Angel answered. Angel answered the skeletal one. Give you a minute to read what the angel write. Okay, the angel wrote a very detailed answer to help the student who asked the question. Okay, I will not want to know who the angel is, but thank you, the angel. Thank you, angel, for helping. Okay, let's look at how to do it. Okay, now in this case, they say that the commonly used solvent is YIJC, one of the products of hydrolysis. So the first thing you know is that this is actually a hydrolysis process. Okay, so given that it is a hydrolysis process and given that your product is a alcohol, okay, you can guess that if I have a hydrolysis process and an alcohol, what is likely to be your product, your initial electrolyte, the organic solvent. Okay, you notice that if I hydrolyze something, okay, I will get the common one is actually what? You have your COH, your NH2, and your OH, right? If I hydrolyze my ester, I will get a COOH and an OH. If I hydrolyze my amide, I will get an amine and a COH. Correct? Or COH, yeah. Okay, so that is how you go through your hydrolysis. So in this case, if you notice that there is already two OH groups here. Okay, so the compound given is C3H4O3. Okay, so if I have three carbons and three oxygen, and I know that my final product needs to have alcohol. Okay, so I know I have this already. Okay, or you want me to draw it out also can. Okay, this is what I get. So I draw this out first. And after that, you notice that it's a hydrolysis. There is only one more O. There is only one more O and one more carbon. One more O, one more carbon. It cannot be a straight chain anymore. So the next best thing you can think about is your ring. So that is why you can club this out to get this. And that is where this part is actually this part. Okay, so you just need to fix step 2 in and you will get the answer. Can? Okay, the keyword here is skeletal. So you make sure you draw it in a skeletal form. When you transfer, oops, sorry. When you transfer, you make sure you transfer to the skeletal form. Can? Okay, 5A, 5B, 5C, 5D, no 5G. Okay, the next one is 5G. 5G. Okay, 5G Angel also answer already. Okay, where's my 5G? Wait. 5G, yeah. Okay, 5G is here. It is a one whole long process that is given step by step. Okay, I think this database is very nice, very kind. They give you a lot of things already. You just need to plug everything in and you will be able to see it. Okay, now this one. Okay, there is a question to ask. Why is it that the number of electrons need to divide by 4 to account for the amount of Li in the overall equation? So if you notice this one, right, I want you to zoom into the fact that every mole of Li plus take in 1 mole of electrons. Okay, so if there is 4 moles, even if this part here, I times 4, okay, it's also for 4 moles of lithium plus. So every mole of lithium take in only 1 mole of electron. So if you have your Q equals to IT, Q which is equals to NF, then your N will just be 1. Okay? I think nothing much for this. we are pretty good with this paper. Anything else that you would like to ask? If not, then I will stop share first and stop recording first.